So the next lesson we're working on is called equivalent trig expressions. So this is just a little quick introduction to the idea because these two triangles are really going to help us with the lesson. So I've tried my best. I'm not really artistic, but these two triangles are congruent. Okay, and I've said that this angle here is theta, and if this angle here is theta, this angle must be complementary to theta, so it's pi over 2 minus theta because we're working with a right triangle. And I've also labeled the side lengths A, B, and C here. So if these two triangles are congruent, then the hypotenuse for this triangle must also be C units. And this here is A, and this here is B. Okay, so let's work with sine theta. We want to find sine theta. So regardless of which triangle you look at, sine theta will be equal to opposite over hypotenuse, A over C. And let's work with tan theta. Tan theta is opposite over adjacent, so it's A over B. And secant theta, now be careful, secant is reciprocal of cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. So hypotenuse over adjacent should be C over B. Okay, that shouldn't be too bad. So like I said earlier, I'm going to break down the 6 trig functions into 3 pairs. So hopefully you know the friend of sine theta is cos theta. Okay, but what I'm going to do is I really want to find the same ratio. I really want to keep A over C. Cosine of what is equal to A over C? Adjacent over hypotenuse. So how about we use pi over 2 minus theta? Interesting. So we talked about this earlier when we talked about special angles. If the angles are complementary between sine and cosine, you'll get the exact same ratio. So for example, sine of pi over 3 is equal to cosine of pi over 6 because pi over 3 and pi over 6 are complementary. So we have A over C, A over C. Okay, let's do the next one. Tan theta is equal to A over B. How else can I get A over B? What is a friend of tan? How else can I get A over B? A over B, but instead of using tan, I can use cotan. Cotan of pi over 2 minus theta, because cotan is adjacent over opposite. Interesting. So I can generate the exact same ratio using tan and cotan by using complementary angles. Okay? So secant, how about, okay, I don't want to spoil it for you, but C over B, how else can I generate a ratio of C over B? C over B, how about we say hypotenuse over opposite? So this is cosecant of this angle, pi over 2 minus theta. So between the 3 pairs, the one we're really good with is sine and cos, because that's the one we talked about earlier when we talked about special angles. But actually, the relationship keeps going. So sine and cosine, tan and cotangent, secant and cosecant. So you can generate the same tan ratio, for example, using cotan by using the complementary angle. You can generate the same ratio between secant and cosecant by using complementary angles. So there's an additional relationship that you might not have seen between the 6 trig functions, because when you first learned the 6 trig functions, you did sine, cos, and tan first. Okay, and then you learn about the reciprocal trig functions or the secondary trig functions. But what you could have done is learn sine, tan, and secant first, and then learn the other three cos, the cosine, the cotangent, and the cosecant. So this is how we want to study or look at the 6 trig functions for the coming lesson, because it's all about equivalent trig expressions. So equivalent trig expressions, I just want to focus on equivalent expressions because that's the idea you want to focus on. So in grade 9, you did something like that, 3 times x plus 2. And you would say, obviously, that's 3x plus 6. So these two expressions are equivalent. Yes, they look different, but mathematically, they're equivalent. What else do we have? In grade 10, you might have done something like this. And the expanded, 21 minus 2 is 19x. Once again, they look different, but they're mathematically equivalent. I can keep going on and on, but you've been doing that in grade 9, 10, and 11. Expressions that look different, but mathematically they're equivalent. So we're going to combine these two ideas and talk about equivalent trig expressions because there's a lot of really cool things with the unit circle that we're going to look at. So I'm just going to do one equivalent trig expression. I'm going to do it in degrees just to keep you comfortable. So sine 10 degrees is equal to sine 170 degrees. These two equivalent trig expressions. Sine 10 is exactly the same as sine 170. Let's keep going. Sine 10 degrees is equal to cos 80 degrees. That also works because 10 and 80 are complementary. Let's do one more. This is going to be the most exciting. Cosine of 2, so 360 minus 80 is 2, I'll have a brain fart. 360 minus 2 minus 80 is 280. So these two are also the same. Now why is that the case? Because, well, if cosine of 280 is equal to cos 80, and cos 80 is equal to sine 10, then we can say cos 280 is equal to sine 10. So we'll study a lot of different trigonometric relationships, but these two triangles really form the basis of the relationships between the 6 trig functions.